So resolving a vector examples, it is not necessary that the horizontal component is always with cos theta and vertical is with sin theta, depending on the angle. So example, a force is there which is making angle 30 degree, which is a force of 30 Newton, and it's making angle 20 degrees with x-axis. Okay, and the question is find the horizontal component and the vertical component. So how I can find the horizontal component? What will be the horizontal component here? The horizontal component will be 30 cos 20. And what about the vertical component? The vertical component will be 30 sine 20. But if the angle was different, like example, the same force of 30 Newton, but the angle instead of given with a horizontal, it was given with vertical. So this angle was given. It was making angle 70 degrees. So in this case, if I need a horizontal component and I need a vertical component, if I need a horizontal component and I need vertical. So in this case, the horizontal component, because the component which is against the angle is always written with sign. You can see the component which is against the angle is written with sine, or it just next to the angle is written with cos. So here it is making angle 70. So component which is against the angle is written with sine, and next to the angle is written with cos. So this will be 30 sine 70, and this will be 30 cos 70. So you have to check which one is given, which angle is given. If angle with x-axis or horizontal is given, then the horizontal component is written with cos and vertical is with sine. But if angle with y-axis is given, then I will write it here. If angle with x-axis is given, then the horizontal is f cos theta, and the vertical is f sine theta. But opposite will happen. If angle is given with y-axis, then this will be horizontal, and the other one will be vertical. Is it clear? Any doubt in this part? The components, resolving the vector into component horizontal and vertical. Any doubt, Iftikhar? Okay. So if I give a question, a force is there of 70 Newton making angle 20 degrees, and you want to find the horizontal component, and you need the vertical component. So what we can do to get the horizontal and the vertical component, the one which is against the angle, here in this is a horizontal component towards right and vertical component down. So the one which is against the angle should always be written with sine. So this will be 70 sine 20, and with an angle next to the angle, that is 70 cos 20. So the horizontal component in this example is 70 sine 20 degrees, whereas the vertical component is equals to 70 cos 20 degrees. Is it clear? Yeah, what about others? Is it clear to everyone? Now, for a graph, and relation between the quantities, so graph and relation between the quantities, if two quantities are directly proportional, so what should be the graph between the two quantities? It should be a straight line graph which is starting from origin. So when we plot a graph between the two quantities, it should be a straight line. So straight line graph starting from origin, and the ratio at any point, it will have a constant slope because it's a straight line, and the ratio of the two quantities will be constant. But if two quantities are inversely proportional, then the graph, it will be a curve between the two quantities, it will be a curve, and the product should be constant. So the product of the two quantities will be constant, and it will be curved, so you can identify they are inversely proportional to each other. But for example, if the straight line, but what happened, it is not starting from origin, so we don't say it is proportional, we call that as a linear relation. And if it is a curve but the product, so we call that as a non-linear relation. So this is a linear is means that straight lines are there, non-linear means it is curved. So using a graph, how we can identify the relation between the two quantities, and how we can predict whether the graph will be a straight line or what will be the gradient. So identifying the shape of the graph, and finding gradient using equation. So how we can predict, identify the shape of a graph, or how we can predict the relation between the two quantities, or shows that what will happen to the two quantities, like linear relation, non-linear relation, it's directly proportional or a straight line. So what we will do, we will compare this, use this equation y is equals to mx plus c. What is y? Means the quantity on y-axis, that's y. What is m? Is a gradient. So y here refers to the quantity on y-axis. What m refers to? It refers to the gradient, the slope. What x refers to? Quantity on x-axis. And what c refers to? It refers to y-intercept. So y is equals to mx plus c. We use this equation to find a relation, or what kind of graph is there between the two quantities if we plot. Like example, I have this equation f is equals to ma, okay? And I want to find what kind of graph will be there with the equation, how I can predict what kind of graph will be there. So what I will do, if I say if force is on y-axis and A is on x-axis, predict the graph. So how you can predict the graph? So what you will do, you will write the equation y is equals to mx plus c. So on y-axis, if I have force, so I have a graph, I'm plotting a graph. On my graph on y-axis, I have force. On x-axis, I have a, acceleration. So I have a, acceleration. What is a y-intercept? Y-intercept means, like if you have a graph, if it touch the point where it touched the y-axis, that's called y-intercept, that's c. This is positive y-intercept, and it can be negative y-intercept, or it can have been zero y-intercept, could be zero as well. So in this example, because the equation is f is equals to ma, there is addition of a zero, so I can say the y-intercept is zero. So this shows that the y-intercept is zero, and what will be the gradient? So the gradient is equals to mass, and we know mass of an object is constant. So if mass is constant, it means the gradient will be constant as well. So mass constant, we can also say gradient is constant. So if gradient is constant, what I can say? I can say if I plot a graph between force and mass, so it will be a straight line with a constant gradient and starting from origin. How I say starting from origin? Because you can see the y-intercept is 0. If this value of a c is 0, it will start from origin. If it is positive, then it will be above origin. Negative, it will be below the origin. And how I can say it is a straight line? Why it is a straight line? Because a gradient involve a constant. So when a gradient involve a constant, it shows it should be a straight line. Is it clear? Is it clear, this part? How, what will be the shape of the graph? So like this, you will have different equations and you have to work out what will be the gradient. Another example I'll give related to this. Example, I have a falling object. So initial velocity is 0. And as it is falling, it's under the effect of a gravity, so acceleration is due to gravity. And the speed after some time is v, the final speed. And it cover distance s. So you have the equation 2as is equals to v square minus u square. And I want to plot a graph or find the gradient by using the equation and example. When v square on y-axis and x square and s is on x-axis. So we have to find the gradient by using equation. And when v square is equals to, v square is on y-axis and s is on x-axis. So first thing, when I substitute the value, so 2, as we know, acceleration is due to the gravity, so g s v square, and u is just falling object, starting velocity is 0. So I can say 2gs is equals to v square. But the problem here, because I have this equation y is equals to mx plus c. So the quantity which is on y-axis should be on the left hand side. But in this one, quantity which I'm plotting on y-axis is on the right hand side. So first I have to rearrange the equation. So when I rearrange this equation, I can also say v square is equals to 2gs. I just switched the whole equation. Now I can compare y is equals to mx plus c. So if on y-axis I have v square, so on y-axis I'm plotting a v square. On x-axis I'm plotting a distance. So what will be my gradient? What I'm left with? I'm left with 2g. So the whole gradient will be 2g. 2 is a constant number is there, and g is the acceleration due to gravity, that's also constant. So it shows it will be a straight line. But whether this straight line is passing through origin or it is above origin or below origin, as you can see here, the starting velocity u is also 0. So y-intercept is 0. So if y-intercept is 0, it shows there will be a straight line, and then straight line is also passing through origin. Is it clear? Any doubt in this part? If you have any doubt, you can ask. Okay. So some question related to SI quantity. Which of these unit is same as Newton? Which one is same as Newton? What's the answer? A, B, C, or D? So Newton, as we know, F is equals to ma. Everyone should participate, so it shows your understanding of the topic. So F is equals to ma, and mass is kilogram, acceleration is meter per second square, or we can say kilogram meter second minus 2. So kilogram meter second minus 2, B is the right answer. The reason I'm solving these questions so that you understand the topic, what we discussed today. A football is kicked at a speed of 12 meter per second, making 35 degrees to the horizontal. So means the velocity is 12 meter per the speed is 12 meter per second, and it is making angle 35 with horizontal. So the question is horizontal component. Which one is a horizontal and which? So there are always two components. We need only horizontal component. So how we can find the horizontal, the component which is with an angle? So this will be 12 cos 35. And against the angle, it will be 12 sine 35. So what's the answer? It will be A, 12 cos 35. Which of the following is a scalar quantity? Which of the following is a scalar quantity? For this, everyone should participate. Your time, C is the right answer. Which of the following is not a SI base quantity? The force is not an SI based quantity. Force is a derived quantity. Which table correctly is correct for scalar and vector quantities? So scalar have magnitude but no direction. Vector has magnitude and has direction as well. Which of the following is not unit of energy? Leave this part because it's related to energy part. Now, a body is acted by the vertical and horizontal force. So basically you have horizontal force, okay? And the vertical force, the horizontal force is 32 and the vertical force is 18. So to get the result, what you will use? You will use a triangle method, tail of the first to the head of the last. That will be the result. And it is making a right angle triangle. So I will find the magnitude by, if I need a magnitude of this resultant, it is because this one is hypotenuse, base, perpendicular. So to get the resultant, it's equal to hypotenuse base square plus perpendicular square. Because we know hypotenuse square is equals to base square plus perpendicular square, or I can say a right angle triangle Pythagoras theorem. So 32 square and 18 square in a root, I'll get the magnitude. But how to get the direction? So to get the direction, this one is perpendicular and base. So if I need this direction or angle, so angle, as we know, tan theta, tangent theta is perpendicular over base. So tangent theta is perpendicular over base, or we can say tan theta is perpendicular is 18 and the base is 32. But we need theta. So theta is tan inverse 32 by 18 by 32. So what is the right answer? B is the right answer. Is it clear how we work out the angle if we know the horizontal and the vertical components? So using a right angle triangle or Pythagoras theorem, we worked out this. So if we know horizontal and vertical component, we can use that triangle method, get the result. And if it's making a right angle triangle, Pythagoras theorem to get the magnitude, and using a trigonometric ratio, tangent theta, which is perpendicular over base, we can find the angle. A body is acted by vertical force, and that's the same magnitude I just discussed with you. Which of the following is a vector quantity? Which of them is a vector quantity? So in this one, the vector quantity is, the force is a vector quantity. Which statement about the scalar and vector quantities is correct? So vector have magnitude and direction, but scalar have only magnitude but no direction. So in this one, C is the correct answer. Which of the following is equivalent to Pascal? I can give you a hint that Pascal pressure is force over area. Which is equivalent to Pascal? A, B, C, or D? Yeah, so when we work, as we know, Newton is kilogram, meter second minus 2, and area is meter square. So this time will cancel and it will move up. So it will be kilogram, meter minus 1, second minus 2. That's why C is a right answer. A model boat is crossing a stream. A model boat is crossing a stream. The stream is traveling east at a speed of 1.5. So it's, as we know, the directions, the compass, north is up, south, east is towards right, and west. So stream is head moving, it's east direction 1.5, and a boat is heading north. So boat is going up. How I can find the resultant? So what will be the answer if I need the resultant here? It is making a right angle triangle. Yeah, I will use the Pythagoras theorem. Base square plus perpendicular square is equals to hypotenuse. In a square root gives hypotenuse, which is the Pythagoras theorem. And if I need angle, if they ask for angle this with the x-axis, so this theta is equals to tan inverse perpendicular, which was 0.5 divided by base equals to 1.5 if they ask for angle. Which of the following is a derived SI unit? Derived SI unit. There is SI unit and SI quantity. Quantity is the physical quantity, like unit, which like unit of time is second. So time is a quantity and second is a unit. So which one is a derived SI unit, not quantity? So power and time are the quantity, so it cannot be, these two are the units, and this one is SI, the base. So A is the answer, which is, they're asking for derived SI unit. So C and D are the quantities. Power is a quantity, time is quantity. So they're not asking for quantity, so this cannot be. Now you're left with joule and meter. Meter is a SI base SI unit, not the derived. Like joule, newtons, Pascal, these are derived SI units. Is it clear? An airplane is flying horizontally, heading towards north. Its speed through the air is A, and the wind is blowing east. So airplane is heading towards north and wind is blowing towards east. The resultant is from tail of the first to the head of the last will be the resultant. So how to get the resultant here? Because we need this part as a resultant. So resultant, what will be the answer? Yeah, that will be D. Again, you use the Pythagoras theorem to do this. And if we need angle, the same question, if we need an angle, angle from a north at which the plane is, so we need this angle because there's a north direction, we need this angle. So according to this angle, we have a base and we have perpendicular. So tangent theta is perpendicular over base. So theta, the perpendicular is equals to B and base is equals to A. So, and it will be tan inverse B by A. So D will be the answer. Is it clear? Any doubt related to this? I will share this file with you as a weekly homework so you can go through this file and solve. And a weekly homework, like every week I will discuss. So you have to solve. I'll share the answer key marking scheme also with you. So you can only discuss the doubt before the next class or at the beginning of the new class. So I'll end the session and share the recording with you.